Now see a AC circuit containing resistance only. Suppose you have taken a circuit here where resistance R is connected and AC source is connected with the help of the switch here. This is the symbol for the AC source and this is the resistance R. So, when you apply EMF at an instant, that is E is equal to, you write E sin omega t. And now current can be calculated in this circuit, I is equal to E upon R. So, that is here E naught upon R sin omega t, and that can be written E naught upon R is the peak value of current, that is I is equal to I naught sin omega t. So, when we look at these two equations, this and this, we find here there is no phase difference between these two equations. It means current and EMF are in the same phase in the AC circuit containing resistance only. So, when you draw the graph for this, the sine curve, that will be like this. Here you are taking here E and here I can take also I, and that is the time here. The graph is like this. So, this is representing EMF and dotted line is representing I. So, the variation of E and I with the time is shown here, that is which is the sine function. So, from these two equations, it is very much clear here there is no phase difference between these two. So, that means when the EMF is maximum, current is also maximum, when the EMF is 0, current is also 0. But see here, EMF and current both are a scalar quantity. So, they cannot be represented by, we cannot write them as a vector, but we use here a vector, or you can say the phasor diagrams here, which are basically here the vector which rotate about the origin with the angular speed omega. So, what we do here, we take here the origin and these are the axes here. Suppose here this you have taken, this is x and this is y here, and E naught and I naught are represented by the arrows which are known as the phasor. So, we know the equation like this, E naught is equal to E is equal to E naught sin omega t. So, omega t is the angle here. So, now somewhere it is here. So, this is the vector which rotate about the origin with the angular speed omega. So, this can be represented by omega t, and this arrow is known as here E naught, that is the peak value of EMF, and these arrows are basically called also the phasors. Similarly, since E and I both are in the same phase in case of the resistance like I naught sin omega t, so we can also represent here I naught. At any time here, these are the projection of these E naught and I naught on this perpendicular axis here will be telling you the instantaneous value of current or EMF. So, this is the phasor diagram for the AC circuit here containing resistance only here.